So I want to remind you about the right-hand rule, which we use for trying to figure out the direction of the result of a vector or cross product. Now, with the right-hand rule, it sounds like kind of an obvious piece, but the single most important mistake that I want to try to avoid anyone from making is always make sure you're using your right hand and not your left hand, because they're mirror images. And if you use the left hand, you're going to get the exact wrong result. So, what I tell folks, if you're left-handed, you have something in your left hand, you're at an advantage. If not, and you need to use the right-hand rule, put something in your left hand so you can't use it to do the right-hand rule. Now, if you have something in your left hand, take your right hand and start by pointing your fingers in the direction of the first vector you have. So, for example, say there's my first vector. And that's my second vector. So my fingers are going to line up exactly like that first vector. Then I want to rotate my palm so that however I would have to rotate it, vector B would be coming out of my palm. The second vector is coming out of my palm, and then I close my fingers from A to B, and the thumb points in the direction of my result. So if A and B are on the X and Y plane, that means your thumb is either going to be coming out of the board or into the board, which is how we do most of our cross products that we have to do in physics. But the last piece that I just want to mention is this little coordinate system I've drawn in the corner. And it's called a right-handed coordinate system because its layout is based off the right-hand rule. Now, to try to figure out directions, you could sort of play around with the right-hand rule for all possible permutations, but at some point with using the right-hand rule, you're doing some really weird gymnastics with your arm, so rather than dislocate shoulders, here's a little shortcut to the right-hand rule. Start, if you can, by making the Vulcan salute, or you could make like a little finger gun. Both work equally well. And then what you want to do is pick a starting point. So since the textbook right-hand rule says point your fingers, start with your pointer finger. Then take your second set of fingers, bend them at a 90-degree angle. So this is going to be your first vector, your pointer fingers. This is going to be your second vector, the middle if it's in a finger gun, or the other two if it's in a modified Vulcan salute. Your thumb is going to give you the direction of that third axis. So that's why if X is along the horizon and Y is straight up, Z is coming out of the board. And yeah, it's biased to right-hand people, which is why they called it the right-hand rule, but that's what most mathematicians in continental Europe and in Britain happened to be during the 1800s when we came up with this rule. Thanks for watching.